I'm going to be the solutions architect presenting for you tonight or this afternoon, depending on which time zone you're joining us from. Today's topic is going to be about understanding AWS options, storage options. Now, in terms of storage options, before we jump into that, I want to take a few minutes to talk about Amazon Web Services and the infrastructure that we globally have. We then look at the different storage options that you can select on the AWS platform. Eventually, we're going to have a look into how we get our data inside AWS, and we're going to leave some time to actually demonstrate this to you into the console. So stay tuned. I'm going to actually click myself to our interface later on, and you can see live in the demo how to do things. And after that, you're going to see what's next. Now, first of all, Amazon Web Services has a global infrastructure footprint. We have about 11 regions all over the world where we have, including the storage option that I'm going to present today, a variety of services that help you complement your workloads. Within those regions, we have what we call or refer to as availability zones. Every region always has at least 2 availability zones, and those are distinct locations within those regions, and we have clusters of data centers within those availability zones. Beyond that, we have about 52 different edge locations across the world that can also help to accelerate your web application delivery or your DNS resolution. And we keep on continuously expanding those regions across the world. So one of the latest regions that we just opened up is the one in Frankfurt within Germany. And we keep on expanding on those regions. Now looking at Amazon Web Services, we actually have a variety of services that are powered by this AWS Global Infrastructure that I just talked about. Some of those services we like to refer to as foundation services. Some of them are higher level services, application services, etc. Today we're going to look at the foundation services, which are things like compute, storage, database, and networking services. Today's focus is going to be specifically around the storage options, the storage services that AWS offers you. Talking about AWS storage options, I would like to dissect this into a variety of different storages and which storage options and which services actually power those storage options. So we look into what is an object store, what is an archival storage, what is kind of a block storage, and what are the services that Amazon offers around it, and also what kind of gateway solutions we offer you to connect your on-premise data centers or offices with AWS. Starting with object storage. AWS offers a service which is called Simple Storage Service. In short, we also like to refer to it as S3. Now, S3, or the Simple Storage Service, is a highly scalable, fully managed object storage. Well, what does that mean? Basically, you can have any kind of object, which means any kind of block data, think videos, images, text files, etc., which you can put in what we refer to as buckets. Now, interestingly, this storage service has no storage capacity, so it's basically virtually unlimited in the kind of size of data that you can put inside the service. The only limitation that we impose is actually per object. So we can, per object, and the size can vary between 1 byte up to 5 terabytes, but you have unlimited storage capacity on how many objects you put inside. And to give you a bit of an idea on the size of S3, currently we have over a few trillions of unique customer objects, and currently we're handling over millions of transactions per second. So it's a service that can scale to any kind of capacity that you require. And one great advantage of the Simple Storage Service is its high durability. It is designed for 11 nines of annual data durability. This means that out of 10,000 objects, the highest risk that you would take is to lose 1 in 100 million years. Now looking at our Simple Storage Service, how would this compare to traditional storage? I mentioned virtually unlimited capacity. Well, what does that mean? Basically, with Amazon S3, you do not need to tell us how much storage you're going to consume. Within the traditional storage, within your data center, this might be very different. You're going to start off and provision certain raw storage. You're going to buy hard drives. Imagine this would be 1 petabyte of data where you're going to purchase raw storage. Now, if you want to ensure a certain durability on that raw storage, very often you need to do certain forms of operations like RAIDing and clustering to achieve a kind of a higher durability. Now, if you do that on 1 petabyte of storage, very often your actual usable storage is much lower. On top of that, if you put a file system on top of that to make that storage usable, again, you might have a certain form of compression here, and suddenly you're only bound with 600 terabytes of actual allocated storage. Now, looking at your actual needs of your application, very often you do not consume 100% of that allocated storage. You might just consume a certain subset of that storage that you have allocated, and the application data might only be as big as 400 terabytes. Now, how does that translate into Amazon S3, the simple storage service? Well, basically, you put the data inside that you're going to use. You do not need to tell us how much raw storage you're going to allocate. You actually just pay exactly for what you use to whatever capacity you require. Now, how does the simple storage works? Well, basically, we have so-called buckets and the objects that you place inside the Amazon S3 service. First of all, it's a fully managed service. So you don't need to worry about where data is stored, how does that work, how to achieve a high durability. You basically just put your objects inside and we manage the rest. These objects are put in so-called buckets. Now, S3, or Simple Storage Service, also allows you a variety of options to enable them on your bucket. So, for example, you can enable versioning, which allows you to keep off the same object different versions of the file within your Amazon S3 bucket. You can also control the access that you give to the objects within the bucket to so-called bucket policies or access control lists. If you're concerned about security, very often you want to ensure encryption at rest of your data. With S3, within a click of a button, you can enable an AES 256-bit encryption at rest of your data. Any object that you're going to put within the simple storage service is private by default. However, if you desire, you can make this object addressable over the internet. You can make it public, and you get a public endpoint for that object name. And if you have a look on the left side on the picture here, we give you an example of how this would look like. You get an actual URL with your bucket name, and at the end you have the object name, and it can be accessed via the internet if you desire to do so. Now, this makes it an ideal place for images or videos or application data of your web application. And given its high durability, it's also great for backups. Now, interestingly, if we make objects available via the internet, we could think about different ways of using the simple storage service, such as, for example, hosting a static content website. S3 is not only great to store objects in a highly durable manner, but it's also great to replace your web server for any kind of static assets that you have, such as, for example, images, HTML files, or style sheets like CSS, JavaScript. You can put this in a bucket, and basically you can offload your entire static content into your simple storage service. And that allows you to run a web application and offload all that static content from a dynamic content. So the dynamic content that you would otherwise run within your virtual service, or as we like to refer to it, EC2 instances within AWS. So when is an object store like S3, the simple storage, useful? Well, basically, Amazon S3 is great when you need storage capacity that is web scale, that is virtually unlimited, and a performance that can scale within your web applications without the need to provision this up front. It's great for any data that has very high durability requirement. S3 is designed for 11 nines of annual data durability. So it's, for example, great to store log files. It's also good to perform backups or keep active archives within the S3 service. Another great use case is if you have videos and you want to use S3 as a single origin store to deliver your video to a content delivery network, such as, for example, Amazon CloudFront. And a lot of our customers also use S3 as an ingestion point for any kind of big data applications, data points that they're logging into a highly durable service. Now, one example of this would be one of our customers, Yelp. Yelp actually allows you to write reviews about certain points of interest in a city and find interesting places to have food, for example. How is Yelp using S3? Well, basically, they store all their daily logs within an S3 bucket. They also store all the images, such as, for example, this little food item that you see on the left side within S3. Now, if you look at the logs, they generate more than 1.2 terabytes of data on log data every day. And they actually run a MapReduce cluster, so-called Hadoop, with over 250 different jobs per day. And as such, they process more than 30 terabytes of data every day through our S3 service. Now, moving on, how about archival storage? We have a service within Amazon which is called Amazon Glacier. Amazon Glacier is a very effective service if you want to archive data at a very low cost for a longer term period of time. It's great if you have infrequently accessed data. Think about things such as log files that you need to keep for a longer period of time for compliance, and you don't want to keep them within your S3 service because you want to reduce your cost further. Within Amazon Glacier, we talk about 1 cent per gigabyte per month in various regions, which would equate up to only $120 per terabyte per year. A great place to archive all your important data that you cannot lose. Because again, Amazon Glacier is designed for 11 nines of annual data variabilities, such as S3 too. Now this leads us to the question, well, when to use Amazon Glacier and when to use Amazon S3. Within the Amazon Glacier service, retrieval time can sometimes take up to 5 hours, while as with S3, it's an immediate retrieval time. So we have to have a look at what are the storage costs associated to what we're going to store, and what are the retrieval costs? How often do we retrieve data? If it's relatively hot data, we probably want to leverage S3. Otherwise, Amazon Glacier is a perfect place to archive all your data at a very low cost. Now, Amazon S3, the simple storage service, and Amazon Glacier have a nice integration. They allow you to do so-called policy-based archiving. Well, what does that mean? Basically, within all the objects that you store within the Amazon S3 service, you can set a lifecycle policy on your S3 bucket. This allows you to move objects based on their object age automatically into our archival service. So you could, for example, say that after 30 days, you might want to move your log files into your archival service. And furthermore, this lifecycle policy also allows you to say that you want to delete objects after a certain period of time. So you could, for example, think about setting a lifecycle policy that moves objects to Amazon Glacier after 30 days and would delete those objects after 365 days, so after a year. I'm also going to give a demo of this lifecycle policy later, so stay tuned for that. Now, a good use case of one of our customers is SoundCloud. SoundCloud is one of the world's leading social sound platforms. It's a very interesting platform. You can upload your sound files, then you can see the waveforms later on, and people can listen to your sound, to your music that you uploaded and comment on it. Now, interestingly, SoundCloud obviously needs to transcode those audio files. What are they going to do with the raw data? Well, they use Amazon Glacier to put all the raw uploaded audio files inside there. And then they're going to transcode those audio files to a format that is better suited for online delivery via their website. And those transcoded files, they serve up from S3. They put them in our simple storage service. And since Amazon S3 allows you to get a public access to the object, they can directly serve up those transcoded files from S3 itself, removing the need of running an actual web server for the delivery of their sound. And they store about 2.5 petabytes of data as of now, and it keeps on growing. And the interesting part is they never had to provision those. Amazon S3, the simple storage service, grew just as they put data inside. Moving on into the different kind of storage. Now we're looking at block storage. Within Amazon Web Services, you can provision virtual servers, run your own operating system environment, and, for example, use it as a web server, an application server, or whatever your requirements are. Those virtual servers are called EC2 within Amazon. This stands for Elastic Compute Cloud. Now, every one of these EC2 instances, with a few exceptions of smaller instances, always come with a so-called instance storage. This is a local, directly attached storage resource that you get with your virtual server. Now, the size of that instance storage depends on which virtual server, which EC2 instance type you are selecting. So, for example, we have specific EC2 instance type that are optimized for compute. Others are optimized for memory. And then we also have EC2 instance types which are optimized for storage. This allows you to have local instance storage that can allow you to have up to 365,000 reads per second and up to 350,000 writes per second. It's a great place to, for example, run some of your NoSQL databases such as HBase or Cassandra or MongoDB. And depending on the EC2 instance type, you also have the choice between SSD or magnetic instance storage that is attached to it. Now, one little word of caution. The EC2 instance storage is actually volatile. This means that data will not persist when you stop your virtual server or when you terminate it or when it should fail. So it's only well suited for data that can be volatile. Now, how about persistent data? Often we want to persist data that we actually write to our block storage. For this, we have a service called Elastic Block Store, or in short, Amazon EBS. This is a high-performance block storage. Well, what does that mean? You can create a so-called EBS volume, which you can attach to your virtual server, so your EC2 instance. You can then mount it and run any kind of file system on top of this Elastic Block Store. These volumes can be created with different sizes in mind. This can range from 1 gigabyte all the way up to 1 terabyte. Now, there's a little asterisk behind here. Recently on our reInvent conference last year, we announced that we also very soon will release larger and faster EBS volumes, where this can potentially go up to 16 terabytes. With Amazon EBS, you have the choice between SSD-backed volumes or magnetic volumes. The throughput that you can have with this EBS volume is burstable, or it can be provisioned. Now let's have a closer look at that. What is another interesting feature of Elastic Block Store? You can create multiple volumes, and those multiple volumes can be attached to one single virtual server, one EC2 instance. This is interesting if you want to run a software rate to increase performance or even increase the storage capacity of the volumes that you're running. You can also attach, detach, and reattach an EBS volume to any kind of new instance. Any data that you have written on this block storage will be persisted and will be available for a new instance. This is interesting if you create a virtual server and you want to design it for disaster recovery, where you want to tolerate a failure of a virtual server and flip over the data that you have persisted in your block storage to a new instance. On that note, we also allow you to create so-called snapshots of your Elastic Block Storage. Every volume can be snapshotted at any point in time, and that snapshot will be stored, you have guessed it right, in our highly durable storage service, also referred to as Amazon S3. You can also create new EBS volumes from such a snapshot, or you can even clone individual drives. This is great if you want to create a certain baseline of a virtual server and want to replicate this multiple times. Talking about performance, we have 3 different kinds of Elastic Block Storage volumes that you can provision. We have EBS magnetic, which is magnetic disks, which allow you to have 40 up to 200 input-output operations per second, also referred to as IOPS. Now, when we talk about IOPS here, we actually refer to 256 kilobyte large blocks. So how many reads and writes we have against these large-sized blocks. Obviously, your file system can also have smaller blocks. This is the kind of measurement that we take here. We also have so-called EBS general purpose volumes. Those volumes are SSD-backed, and they have a burstable capacity that can go all the way up to 3,000 IOPS. Now, it's an interesting model here because we actually allow you to aggregate, collect IOPS per second based on the amount of gigabytes that you provision with your EBS volume. And then you can use those aggregated IOPS to burst out all the way up to 3,000. Now, sometimes you want to have a certain consistency around the throughput and the performance that you have per individual volume. As such, you might want to choose so-called EBS provisioned IOPS, also sometimes referred to as EBS PIOPS. These are also SSD-backed drives, and you can provision up to 4,000 IOPS. However, this time around, this is consistent, so you can get consistently the same performance at any point in time. Remember, if 4,000 IOPS might not be enough for your use case, you can always create multiple volumes, stripe or RAID them together, and attach them to your Amazon EC2 instance. Now let's have a look at the different gateway solutions that we offer. How do we connect your on-premise data center, your office, to Amazon Web Services and connect it to their storage solutions? So let's think about a scenario where you have internal storage and you want to have a storage appliance within your corporate data center or your local service then, potentially production systems, and you want to create backups into our Amazon S3 service, our highly durable, simple storage service. This is where the so-called AWS Storage Gateway comes handy. AWS Storage Gateway allows you to connect an on-premise software appliance and provide then integration back into the simple storage service. AWS Storage Gateway basically provides you with a virtual image that you can run on-premise. It exposes certain volumes, the protocol is iSCSI, to your local service, to which your local service can write, and data is automatically replicated back into our simple storage service, into Amazon S3. Now, the AWS Storage Gateway supports 3 different configurations. The first one is gateway cached volumes, gateway stored volumes, and we also support the Gateway Virtual Tape Library, sometimes also referred to as VTL. Let's have a closer look at this. Basically, AWS Storage Gateway gives you a certain virtual machine which you can run on-premise, and this is what you see on the left side in the little blue box. This storage gateway exposes, via the iSCSI protocol, volumes that your service can write to. This data is first then written on directly attached storage area network disks, so any kind of disks that you have on your on-premise service attached to it. It is then replicated via a secure encrypted channel into the AWS Storage Gateway service, which then puts it into the Amazon Simple Storage Service, S3, which is the one what you see on the right. Now, I talked about 3 different configurations options. First one is cached. In the scenario where we opt for a storage gateway that is cached, data is always stored in Amazon S3, but you will keep a copy of frequently accessed files on your actual on-premise host. This is a great way to start extending your storage capacity that you have on-premise with the help of S3. You could have a storage host on-premise that might just have a terabyte, but now through the Storage Gateway service have much more place to actually store your data because it will be pushed and retrieved from S3 with only the 1 terabyte used on your on-premise host to keep the frequently accessed files. Sometimes you want to opt, though, in a scenario where you only see S3 as your backup storage. As such, you opt for the stored volumes. This is an asynchronous point-in-time backup of snapshots back to S3. So whatever data you write from your service onto your on-premise host that contains the AWS Storage Gateway virtual machine, data is stored locally, but a copy will be transferred in the background into the Amazon Simple Storage Service using our AWS Storage Gateway service. I talked about two of those configurations. How about the third one? The third one is the virtual tape library, VTL. This configuration exposes an industry standard virtual tape library to your preferred backup application. Now, what does that mean? Certain backup applications that you currently use might write to actual tape within your data centers. With AWS Storage Gateway service, running it in VTL mode, you can continue to use the backup application that you currently use to write to tape, but you now write to the AWS Storage Gateway service. If you write to a tape, this is abstracted, and that data will actually land in the Amazon S3 service, the simple storage service. If within your backup application you now decide that you want to put that tape into your shelf, well, instead of a robot actually picking up a tape, we now move that data into Glacier. So we abstracted tape into Amazon Web Services, which are designed to be highly durable at a very low cost, without replacing your backup applications that you currently use for your tape backups. Now, AWS Storage Gateway is often used for things like backing up your data into Amazon Simple Storage Service. It is used to perform a disaster recovery of your applications to virtual servers, EC2 instances. Or it can be used to archive some of your long-term data which you don't want to clock your local storage on your corporate data center, and move it to Amazon Glacier, our low-cost, long-term archival service. Let's have a look at the use case. Let's look into the scenario of a disaster recovery. You might run a website which currently is hosted in your co-location data center or your on-premises. This could be mywebsite.com, as you see here on the picture. This might be powered through web server, an app server, a certain database server that has local storage attached to it. What you can now do, you can leverage the AWS Storage Gateway to copy over that data of your web app and database server and have it moved to S3. The Storage Gateway service also allows you to then take snapshots of that data and create so-called AMIs, Amazon Machine Images, which contain a snapshot of the data of your web server, of your app server, or your database server. Now, this now allows you to actually create virtual servers in Amazon Web Services, EC2 instances, and leverage the Amazon Machine Images to boot them up. So this is the snapshot of your server that you have on premise. And this would allow you to fail over your website in case your co-location facility has an issue, in case your data center misfunctions. You just need to then start those EC2 instances, those virtual servers, from the machine images that you snapshotted, and repoint your mywebsite.com to the web server that now runs with an Amazon Web Service. And you reduce your recovery time objective to a very low point. Now, how do we get data into Amazon Web Services? How do we get it into the storage services that we talked about earlier? Well, the first channel which you can push this through is obviously the internet. However, you can transfer data always through a secure and encrypted tunnel if you use the public internet. Any API within Amazon Web Service, and as such all the services that we offer, can be addressed via the secure channel. Sometimes, and especially if you have certain requirements around larger files that you want to transfer, and your internet connectivity might not allow that transfer to happen fast enough, you can also leverage the service we call AWS Direct Connect. This allows you to have dedicated bandwidth between your on-premise site, your data center, or your office directly to Amazon Web Services. And sometimes your data is so large that even 1 or 10 gigabit lines might not be enough to import your data fast enough. In this scenario, we offer a service which we refer to as AWS Import Export, which allows you to have physical media, so think USB sticks or USB drives and have those shipped to our AWS centers. And we will automatically then transfer that data into our Amazon S3, our simple storage service. This allows you to move large amount of data cost-effectively and very fast. Now, looking at all the different storage services, what are some of the reasons why you should consider using Amazon Web Services for storage? The first one is clear. You can reduce your costs. You can reduce your capital expenditure dramatically with increasing scalability. You do not need to tell us what you want to provision. You do not need to plan how much storage you're going to consume in the future. You pay as you go, especially with services like Amazon S3. You put an object, you only pay for exactly what you consume. You also eliminate the need for secondary sites. Our services are designed to be highly durable. You do not need to think about a disaster recovery if you put an object within Amazon S3. This allows you to reduce your on-premise costs. It allows you to eliminate potentially some of your on-premise equipment and manage your archives more effectively. You can think about consolidating on-premise equipment and augment it with the cloud. Sometimes you also want to change processes. You want to eliminate the fact that you need to plan your capacity. With Amazon, you do not need to plan your capacity. You do not need to provision for any kind of peak demand. If you require more storage, you just consume it. And at last, you do not need to worry about all the heavy lifting when it comes to racking and stacking servers that suddenly become old and they need to be replaced. You can remove all this aging technology. Amazon Web Services can take care of you for this. You consume the service. You do not need to worry about the underlying hardware. Think about removing your tape archives. You can use AWS Storage Gateway with your preferred backup applications to easily now move or backup to via the virtual tape library into Amazon S3 or Glacier. And you can cycle out all those aging disk arrays that you might have sitting within your data center. Now, enough of the webinar. It's time for some demos. Let's have a look at how this actually looks within the console and how we can consume this. I'm going to switch to my Firefox web browser. And by now, you should see the Amazon Web Services console. This is after I logged into my account within Amazon Web Services. Here you see an overview of all the variety of services that we offer. And if you attend the webinar week here, we have interesting webinars that talk about a bunch of these services apart from the storage service that we talked about today. Now my demo is going to focus on S3, our simple storage service, how to use lifecycle policies with, how to archive into Glacier with the help of lifecycle policies. And then I'm going to use the elastic block storage, create volumes, and attach those to our virtual service. And then take snapshots of those images. Now let's get started. First of all, I'm going to click here on S3, our simple storage service. Within the console, you will be presented on the left side which buckets we currently have allocated within your account, and on the right side, which properties we have to those buckets. Now for this demo, I'm going to create a new bucket. So I click on Create Bucket up here on the left side. Now, S3 allows me to specify any kind of bucket name. Now, interestingly, this bucket name needs to be uniquely addressable. So you need to choose a name that has not been taken yet. You can then select a region where your data should be stored. And interestingly, S3 is a regional service. As such, data that you put within a bucket within one region will never leave that region unless you create copies and desire to do so. Now, for this demo, I'm going to use the Singapore region. Let's create a bucket, and I'm going to call it Ollie's S3 website. I click on Create. And on the left side, you now see that I created a bucket, Ollie's S3 website. On the right side, I see certain properties of that bucket. I see what kind of permissions I give it. I can enable logging. I can enable things like events when something happens on that bucket, versioning, and lifecycle. I get into that in just a bit. Before that, I double-click on Ollie's S3 website bucket. Now, currently, this bucket is actually empty. So why don't we upload something to this bucket? I click on the Upload button on the left side here. Now, this presents me with the Upload dialog. I'm going to click now on Add Files to upload a file to the bucket. Now, for this, I'm going to use the WEBINAROWEEK header that you saw on our website. So this is going to look like this. It's a PNG file. I'm going to click on Open. After doing so, I can actually click here at the bottom either way to start uploading this object straight away, or I can choose to set some more details to the object that I'm uploading. So let's have a look at what we have here. Now, on this Details dialog, we can actually choose two different options. Earlier, I talked about AES 256-bit encryption at rest. If you want to enable that feature, it's as simple as just ticking this box and then choosing with which key you want to encrypt your data, and it will automatically be encrypted upon upload to the S3 service. Now, we also have so-called reduced redundancy storage. This is interesting. Sometimes you have objects where you do not require the 11 nines of annual data durability that S3 is designed for. Sometimes 4 nines of data durability is enough. And then you can opt to use the reduced redundancy storage, which allows you to store your objects at a lower cost, however, with lower durability. Now, for this example, I'm not going to choose to encrypt, nor am I going to use the reduced redundancy storage. So I'm just going to click on the Start Upload button here. On my right side, I see that my object was successfully uploaded, and on the left side, I see the WEBINAROWEEK header PNG file. Now let me click on this file, and then click on my right side on Properties to inspect this this object. Now you can see that there has been a link created for this specific object here on the right side. However, it has a certain lock in front of it. What does that mean? Well, basically, objects are always private by default when you upload them into an S3 bucket. Now let's test that. Let me click on this link. There we go. Access has been denied. This object is private. However, I want to have something that actually allows me to make this object public. How about I want to actually share this PNG file via the internet? Well, then I can go back onto the object and I can click on permissions and give the permissions that I need. So to allow open and download for everyone. This can be done through the properties page here. Or sometimes you might want to have a shortcut to it. So I can just right click on the object and I say make public. I need to confirm that I now want to make this object. And the object has been made public. Going back to the properties of this, you now see on the left side on the link that this object is now public. Now let's try this. I'm going to click on the link, and there we go. We have now an image, a static asset that could potentially sit on your website, and it has been fully served up from the S3 service without the need of me running a web server to actually serve up this file. Now, this doesn't sound very fancy because this is only an image. How about actually running a website? Well, let's try this. Let's upload a few more files. I click on Upload, and this time around, I'm going to upload also an index.html, which I created previously, and a style sheet. Open. There we go. And I'm going to click on Set Details again. I'm not going to use these features, but I'm going to continue to click on Set Permissions. Now, earlier I showed that an object by default is private, but this dialog also allows me to say that I want to make everything public straight away. It also allows me to set metadata of what those different objects are that I upload. Are they HTML files? Are those style sheets? Are those JPEGs or PNG images? And if I don't want to fill that out, I leave it on this little tick box which says that Amazon Web Services is going to figure out what content types you upload automatically. That sounds good to me. Start upload. And there we go. My files are now uploaded. Now I'm going to click on the bucket here, Ollie S3 website, and then I'm going to click on properties to look at the properties of my bucket. I quickly went through this list earlier, and there's the second item that says static website hosting. So every bucket actually gets an endpoint that allows you to host the static website completely within your S3 bucket, removing the need of running a web server. So let's try this. I want to enable website hosting. I do not only want to have my objects public, but I also want to enable website hosting. This allows me to set an index document. In this scenario, I'm going to make this index HTML. After clicking Save, my S3 bucket is now defined as a static website. And if I click on this link, which is now my static website on S3, it will automatically take me to the index document, which I have set to index.html. So let's try this. There we go. My HTML file has been loaded. We have now hosted a complete static website on S3 using the simple storage service. Fully highly available without the need to maintain any server, even a single server. You didn't need to provision any server for this. That's great, isn't it? Now, let's go back to my initial console. I'm going to go back to all the buckets of my S3 service. I talked about showing you how to create a lifecycle policy. Sometimes I want to put objects in S3, and I want to move them automatically to Glacier and potentially delete after a certain period of time. For that, I'm going to create a new bucket. This time around, I'm going to call it Ollie's Archival Bucket. For this demo, I'm going to choose a different region. So this time around, I'm going to choose Tokyo. And I'm going to create that bucket. There we go. I now have Ollie's Archival Bucket. Now, if I look again on the right side here, we talked about permissions. We talked about static website hosting. There's also capabilities of logging. So I can easily enable logging into this bucket, and any kind of activity of adding, removing, or storing an object will be logged. I can also enable events on the right side here, which allows me to be notified through our notification service or queuing service, or even our brand new Lambda service, and interact upon new put events or delete events within your bucket. You can also enable versioning. This is great if you want to preserve and retrieve different versions of objects that you have stored within your bucket. And lastly here, Lifecycle. This is the one that we're going to use now. So how about I create a Lifecycle rule? For this, I click on Add Rule. Now I can now create a rule for a specific prefix of my bucket, or I can decide to choose the whole bucket to apply this policy. For this scenario, I'm going to use the whole bucket. So let me configure the role. Now, what is the actions that I want to do on objects? By default, I do nothing. Files are stored perpetually until you would delete them. That is not always what I want to do. Sometimes I want to save cost by archiving certain log files, for example, certain objects. Sometimes I might even permanently delete those. I can choose to create a rule to archive. I can choose a rule to permanently delete, or in this scenario, and that's what we're going to do, we're going to do both. We archive and then permanently delete. So how about any object within this bucket, I'm going to push it to Amazon Glacier after 30 days after the objects have been created. This means that any log file that we would place in this bucket, after 30 days, it would automatically be moved to the Glacier storage class, which is much more cost effective. Sometimes I also want to reduce costs by just permanently deleting data that I do not require anymore. So I could, for example, say, after a year, 365 days of the object's creation date, I want to permanently delete this object. Now, after this, I can review it. I can give this rule a name. I'm going to call it the archive and delete rule. I can review what I just did, and if I'm happy with it, I say create and activate rule. As simple as that. On the right side, you now see my archive and delete rule with a typo in it, since this is a live demo. And now all your objects that you move in, after 30 days, they will be automatically moved to Glacier. And after 365 days, so a year, they will be permanently deleted. This was the demo for our simple storage service, lifecycle policies, how to create a static website, and how to archive back into Glacier. Now, we also talked about block storage. So let's have a look at our Elastic Block Storage EBS service. For this, I'm going to click on the Amazon Web Services cube on the top left corner here to go back to my console home. Now you'll find that EBS is not listed on this side. Why is that so? Well, basically because Elastic Block Storage Service, EBS, attaches to our virtual service. As such, you can find it under our virtual service, EC2, the Elastic Compute Cloud. Let's click on that. Now, in previous webinars, you might have seen how to use our EC2 service. And if not, I recommend to you to have a look into some of the webinars around our Elastic Compute Cloud. On this demo, I'm not going to focus on the virtual service where I'm currently run here, my first EC2 instance, but we're going to focus on the Elastic Block Store, which you find on the left side here. We have an item for volumes, and we have an item for snapshots. Now let's start with volumes. Currently, I do not have an EBS volume. Why is that so? Basically, that EC2 instance that I'm currently running does not have Elastic Block Storage. It only uses the instance storage, which is volatile. Now, sometimes I want to create potentially data within that EC2 instance that I want to persist, even if I remove that EC2 instance or if I would stop it. So let's do that. Let's create a volume. First of all, you can decide on which type of volume you want to have. Our current recommendations for most workload is the general purpose, as the name indicates. This is an SSD-backed drive. Sometimes you also need a certain amount of throughput that you need consistency. This is where the provision IOPS, PIOPS is interesting. And sometimes you want to have larger amount of volumes with less throughput, but at a lower cost, and the magnetic ones can be interesting. For this demo, I'm going to use general purpose SSD EBS volumes. Now, the second item then I can specify is the size. How large do I want that volume to be? Now you see this is different from S3. S3 does not make me input what kind of size I want to have. With block storage, I need to give AWS Web Services an indication of how large do I want that volume to have. In this scenario, I'm going to change it to 200 gigabyte. Now, if you look closely, you actually saw that the IOPS indication here jumped up from 300 to 600. Well, what does that mean? Well, with general purpose drives, you actually have burstable capacity, and you get 3 IOPS per gigabyte that you provision. This is the baseline. If you do not consume all this baseline every second, you accumulate those IOPS, and you can burst out up to 3,000 IOPS with this single volume. Now, when you create a volume, you also choose the availability zone. Earlier, I talked about the AWS Global Infrastructure. I talked about our regions, and currently I'm in Singapore. And within those regions, we have the so-called availability zones. If you run virtual servers, you actually decide in which cluster of data center you want to run this, in which availability zone you want to run this. If you want to attach a volume to an EC2 instance, you need to choose the availability zone where the virtual server, the EC2 instance, is running. So the instance that I showed you earlier actually sits in the 1A availability zone within Singapore, the AP Southeast 1A availability zone. So I'm going to select that. That's good for me. And also with EBS, just like S3, we offer you with a simple click of a tick box here to encrypt your volume. Now let's try this. What happens if I do this? If I tick this, I can actually choose a key with which my data will be encrypted on this volume. It will be encrypted at rest. Now at the bottom, it talks about KMS. This is our so-called key management service, which is one of the other services that we also have within AWS. This allows you to manage your different keys and then choose those keys to encrypt different objects in S3 or even encrypt your volumes here within EBS. Now, since this is not a security-focused webinar, I'm just going to leave it at the default master key of the key management system and encrypt my volume with an AES 256-bit algorithm at rest. Now let's create this. Now you see that my volume is being currently provisioned. You can see that the state at the bottom here is creating. Now while we wait for this volume to be created, let's also see how it would look like if we create a different type of EBS volume. So again, let's create volume. This time around, I'm gonna select provisioned items because for a different workload, I might want to have consistent throughput of input-output operations per second on my volume. Again, I'm going to choose a certain size. I'm going to choose 200 gigabytes. And here, by default, we have set 3,000 IOPS. Now, I want full performance of this volume, and I want it consistently. So I'm going to set this to 4,000 IOPS. And this time around, I'm actually going to launch it in a different availability zone, just to have a look how that works. This time around, I'm not going to store sensitive data, so I do not tick the encrypt this volume box. And I click on Create. Now you see that my provision IOPS, referred to as an IO1 volume type, is being created. My general purpose SSD volume that I created earlier is now ready for use. You can see that on the right-hand side here, in its state that it is available. And what does that mean? We now provisioned a volume that is available for us to use. But to actually use it, we want to attach it to a virtual server. We want to attach it to an EC2 instance. How do we do that? We select the volume, and then we click on Actions. And then you can see that I can now attach that volume onto an EC2 instance. So let's try that. I created an EC2 instance, a virtual server, earlier, which I called my first EC2. Now, let's find that instance. Here it is, and it is a running virtual server. I'm going to click that I want to attach this volume onto this EC2 instance. Now, it also allows me to tell the virtual server on which mounting point I want to attach this device, this volume, this EBS volume. So I could, for example, say I want to, and this is for Linux devices, it looks like this. I'm going to mount it to SDE, for example, and I attach it. And now you will see that, again, there's a little spinning circle here because if we look at the bottom here, your volume is now being attached to your virtual server, which I refer to as my first EC2. It's currently attaching. So let's wait for this to be attached. Just going to refresh this, and there we go. Now my volume is attached to the EC2 instance, and that can now be used via the dev SDE mounting point within my Linux to actually consume this volume. Now, to make a little bit of order within my volumes, I can also tag them. One of the most common tags is the so-called name tag, to give them a name. So let's give this volume a name. I'm going to be very creative, and I'm going to call it my first EBS volume. And there we go. Easier to organize. And by the way, you can also filter by these tags. So you can easily find your volumes that you tagged. Now earlier, I also talked about snapshotting those volumes. How does that work? Again, very simple. We're just going to click on Actions, and not only can we detach volumes and reattach them to other devices, but we can also create snapshots. So let's create one. Let's call this my first snapshot. And I'm going to create a snapshot, which is a point-in-time snapshot of that data that currently sits on this EBS volume. I click Create, and the creation process is initiated. I'm going to close this. Now let's have a look at our snapshots. There we go. My first snapshot was a point-in-time snapshot of the data that was stored on the attached EBS volume for my virtual server and my EC2 instance. Now sits in my snapshot console here. Not only do I see and can organize those and again filter it, I can now also create a new EBS volume based on this snapshot. If I want to do this, I click on Actions and I say Create Volume. This will lead me to a dialog which allows me again to create an EBS volume, but this time around not with an empty block storage, but with the snapshot block storage, with the snapshot data. Let's try that. Create. And there we go. We now have a volume with the data that we have within the snapshot. How would that look for the virtual servers? Let's have a look. Let's have a look at our EC2 instances here on the left side. And I look at my first virtual server, my first EC2 that I create. I'm going to scroll down. And you can see that one of these block devices, which is the volume earlier, the EBS volume, is attached to this virtual server. Now, this is more part. It's highly durable. Privately, make them public, and then use S3 as a place to host your static website. We then looked at the lifecycle policies to archive older objects into Amazon Glacier, to also delete older objects after a certain period of time. We then had a look at our Elastic Block Storage Service, EBS, to create volumes of types for different purposes, have some of them encrypted, have some of them made to consume or to offer higher throughput. We attached those volumes to our virtual server, our EC2 instance, and we then created a snapshot of the data of that volume and created a new volume out of that snapshot. Now, I hope this webinar was useful. A few more items that I wanted to mention. This entire week, we run a variety of webinars, and I hope you managed to sign up to a few of those. This Friday, we're going to have a session specifically around your problems. You can ask our AWS solution architects any questions you may have around your specific use case or any architecture requirements that you have. We will be on standby to discuss any of those questions one by one. So please feel free to bring any kind of questions you have around architecture, AWS, cost optimization, some of the features that have presented, or anything related to AWS. Also, over this webinar, I hope that you managed to type a few interesting questions into the question box. On Friday, we're going to take 5 out of those questions, the most outstanding ones, and spend 10 minutes on each to answer them in detail. So don't be shy if you can continue with any other webinar. Bring your questions in, type them in. It will be interesting. Beyond that, don't look at our AWS website. We also have online labs and training that allows you to gain some confidence and hands-on experience with AWS, some instructional videos, and even some self-paced labs. Also feel free to sign up to our instructor-led classes. So we do have trainings in different cities in the world. So get hands-on with an instructor to see what you can do there. And at the end, you might also want to consider to validate your technical expertise with AWS and get what we call AWS certified through our AWS certification. Now, I thank you all for attending this webinar. I hope you find it very useful and interesting. A little kind reminder, as you finish this webinar, as you close your window, you will be asked to complete a survey. It will be really useful for me and my team to understand how helpful this was and where we can improve. Beyond that, feel free to tweet, Facebook, or look at our YouTube videos, and we will also put on slideshare.net the different slides that we shared today with you. Beyond that, feel free to contact us via email. Thank you very much for attending this webinar week. I hope it was useful. Goodbye.